It's been quite a year for fusion energy. December of 2022, Lawrence Livermore Lab achieved its first net energy gain, producing 3.15 megajoules of energy from a 2.05 megajoule input. While not technically a fusion reaction, this was a major milestone nonetheless, proving that we can produce more energy than we consume. Following this achievement, private investment into fusion startups has gone absolutely bonkers. Over $1.5 billion in 2020, almost $3 billion in 2021, and over $1.5 billion so far in 2022. Some of the biggest names in tech have jumped on this bandwagon, including Bill Gates, Jeff Bezos, and Sam Altman, just to name a few. So when can we expect to see the first power plants? Well, let us take a look at some of the most promising projects and what their timelines are looking like. In terms of near-term potential, arguably the most exciting project is MIT and Commonwealth Fusion Systems' Spark reactor, which aims to demonstrate net electricity production by 2025. Spark is a compact tokamak design that aims to leverage high-temperature superconductors to achieve ignition with a relatively small device. This 100-megawatt machine will produce roughly 10 times more power than the 10-megawatt input. If successful, this would be a huge step towards commercial viability. Of course, a 100-megawatt output is not exactly going to move the needle in terms of total power consumption, but it would prove that we can build a compact, cost-effective tokamak that produces net electricity. From there, scaling up to gigawatt-scale power plants would just be a piece of cake, right? Right. Another intriguing near-term project is Helion's Polaris, which is targeting a 2028 goal. Helion is pioneering a pulsed magnetic fusion approach that uses magnetic fields to confine plasma in a unique way. They recently secured a $1.2 billion investment from Bill Gates' Breakthrough Energy Ventures and plan to use the funding to construct their first full-scale reactor. Additionally, they've assigned a power purchase agreement with Microsoft to supply the latter with carbon-free energy once the plant becomes operational. Although Polaris won't produce electricity until 2028 at the earliest, Helion plans to use the reactor to test critical components and systems that will be required for future commercial power plants. Next, we have the big guns. We're talking about megaprojects that will require significant time and resources to complete, but also have the potential to transform the energy landscape if successful. At the top of this list is ITER, the $22 billion international megaproject that is aiming to demonstrate the feasibility of nuclear fusion power. While ITER won't produce any electricity for the grid, it's an essential step towards developing the technology needed for power plants. So when can we expect to see power plants based on this technology? Well, ITER's first plasma is targeted for 2025, with full fusion to follow in 2035, and that is just the beginning. It will likely take several years to design and construct the first power plant based on ITER's technology. Speaking of power plants, the UK's STEP program is also targeting a 2040 first power plant, although this timeline seems overly optimistic, given that the UK's first prototype reactor won't be operational until 2026. China's CFETR, on the other hand, is a bit further behind with a first grid connection targeted for 2050. One of the biggest challenges facing all of these projects is materials. Developing materials that are resistant to neutron damage and can withstand the harsh environment of a reactor is no easy feat. Most of these projects are still in the prototype stage, so it's too early to say how well the materials will hold up. However, if the projects are able to demonstrate that they can operate safely and produce net energy, then we'll likely see a lot more investment and a lot more progress towards commercialization. Now we have to talk about hybrid approaches. Companies like TI Technologies are combining fusion with other energy systems to produce net electricity today. TI's approach uses a hybrid system that combines magnetically confined fusion with inertial confinement fusion. This allows them to produce plasma at much lower temperatures and pressures, which makes it easier to achieve ignition. They've already produced a net gain of 1.5 times using this method. However, this approach comes with its own set of challenges, and it remains to be seen whether or not it will be able to produce enough energy to justify the cost. That said, TI is one of the few companies that is producing energy today, and their technology could potentially be used to complement renewable energy sources such as solar and wind. Finally, it's worth mentioning that even if all of these projects are successful, It doesn't necessarily mean that we'll see a proliferation of fusion power plants. The biggest challenge facing fusion is still cost. Estimates vary, but it's generally thought that fusion reactors will be significantly more expensive to build and operate than traditional power plants. As a result, even if these projects are successful, it's possible that only a few large-scale plants will be built. But let's be optimistic. If fusion does become a viable energy source, the payoff could be enormous. Many experts estimate that successful commercialization of fusion could provide the world with limitless, clean energy at a cost of just 5 to 10 cents per kilowatt hour. That's less than half the price of electricity from the cheapest natural gas plants. And that's why so many investors are throwing billions of dollars at these projects. The potential payoff is just too great to pass up. This has been our channel. If you want more science and tech stories delivered straight to your inbox, make sure to subscribe to our newsletter.